Now let's say we have 4 balls in a bag and all the 4 balls are equally likely to be drawn, which means when I try to draw a ball, it is equally possible that any of the 4 balls will come up. Now all the balls are numbered 1, 2, 3, 4. Okay, so 4 balls are there in the bag, all of them are numbered 1, 2, 3, 4. Then we have defined some events E, F, G. E is the event of getting ball number 1, ball number 2. F is the event of getting 1 and 3, and G is the event of getting 1 and 4. Now we are asked whether these 3 events E, F and G are they independent or not. So whether to find out whether if you have to find out whether they are independent or not, use that formula. So if there are only 2 events and if you have to find out whether they are independent or not, then this one should be satisfied. What is it? Probability of E intersection F is equal to probability of E into probability of F. If it is satisfied, it is enough. But if you have 3 events E, F and G, and if you have to tell that they are all independent, then we have to take every 2 possible events and you have to verify this one, and then you have to take all the 3 and you have to verify this. For example, in this case, if we have to find out whether E, F and G are independent or not, then we have to take them pairwise, which means E and F together and then F and G. F intersection G is equal to P of F into P of G. You should verify this one is valid or not, as well as P of E and G. E intersection G, it should be E into this one. So you have to verify this pairwise, as well as you have to verify all the 3 events taken together, which means P of E intersection F intersection G, it should be P of E into P of F into P of G. So all these 4 should be satisfied. In case if you are having four events and if you have to verify all the 4 are independent or not, then we have to take pairwise first, which means let us say E1, E2, E3, E4, right? Let us say we have 4 events E1, E2, E3, E4. Now if you have to verify whether these are independent events or not, then first you have to test for the pairwise, which means pairwise independence, like this, P of E1 into P of E2, right? Like this you have to test for all the 4, and then you have to test 3 taken together, which means E1 intersection E2 intersection E3. You should test whether it is satisfied or not, P of E1 into P of E2 into P of E3, right? So likewise you will get, I think, three equations, or 4C3 is how much? 4C3 is 4C1, which means 4 equations you will get. Here you get 6 equations, you have to verify all the 6 equations. Here you will get 4 equations, you have to verify all the 4 equations, as well as you have to verify this one also, all the 4 taken together. So that is why, since it is so much tedious, they might not ask you such questions in the GATE exam. They might ask you about 2 events, or at max 3 events. They will not go beyond that. Okay, so all of these have to be verified, and if all of them are satisfied, then only you can say that 4 events are independent. Here we are given only 3 events. Let's see whether they are independent or not. So if the 3 events have to be independent, then all these 4 equations have to be satisfied. Now let's take individual probabilities and then go ahead. We know that since there are 4 balls and all the 4 balls are having equally likely chances, so P of 1 is equal to P of 2 is equal to P of 3 is equal to P of 4, which means probability of getting ball number 1 is equal to probability of getting ball number 2 is equal to probability of getting ball number 3 is equal to probability of getting ball number 4, and all are equal to 1 by 4. And then P of E, probability of getting E event, is nothing but 1 and 2, which means we have to sum of 1, 2. So this has to be taken as if it is union of getting this one and this one, right? So it is not actually drawing 2 balls. It is what is the independently you have to take event of getting 1 and event of getting 2, and you have to apply the union. So probability of getting this one is E is 1 by 2, because 1 by 4 plus 1 by 4. Are you getting this? Right? This is what they are talking about. See, in our experiment, the sample space is containing 4 events, 1, 2, 3, 4, and all the 4 are having equal probabilities of 1 by 4, 1 by 4, 1 by 4, 1 by 4. Now, they have taken two events together, which means 1 and 2 are taken. Then what do you get? 1 by 4 plus 1 by 4, which means 1 by 2. This event is nothing but when you are drawing a ball, what is the probability that the ball happens to be either 1 or 2. So for 1 the probability is 1 by 4 and for 2 probability is 1 by 4, and when you sum them up it is going to be 1 by 2, right? And similarly probability of F is equal to 1 by 2. Similarly probability of G is equal to 1 by 2. Got it? Now let's verify whether these are possible or not. Now what about probability of E intersection F? If you look at E and F, in the E intersection F there is only one event, which is 1, which is nothing but E intersection F is nothing but the probability of getting the ball number 1 when you draw a ball. What is the probability for that? It is 1 by 4. Therefore the probability for left hand side is nothing but probability of getting ball number 1, which is nothing but 1 by 4. Now what about right hand side? The right hand side probabilities are, for P of E it is 1 by 2 and P of F it is 1 by 2. So it is 1 by 2 into 1 by 2, which is equal to 1 by 4. Are you getting this? I am not deriving this probability from this formula. I am verifying whether this formula is valid or not. How am I doing this? E and F, if you take this, we have these two events in E and these two events in F. Now if we take the intersection, it is going to be 1 by 4. The reason is probability of getting ball number 1. So I am computing this independently, right? I am not computing it from this. Then I am computing this independently and I am just checking the numbers. Yes. So this particular property or this particular formula got satisfied. But then we cannot declare that everything is independent. But what we can say here is E and F are independent. That is what we can declare here. Okay. Now see this one. What is the probability of F intersection G? Check that. F intersection G is going to contain intersection in their intersection 1. Therefore it is 1 by 4. And what about P of F and P of G? If you look at P of F and P of G, P of F is containing 1 by 2 and P of G is containing 1 by 2. Therefore it is again 1 by 2. Therefore these two are equal and so it is again satisfied. Formula number 2 is also satisfied. 1 is satisfied and 2 is satisfied. So what can you say from 2? F and G are independent. What can you say from 1? E and F are independent. But then let's see the third one also, the third formula. So what is it? E intersection G. So what is present in E and G? In E and G, the common intersection part is 1. Therefore left hand side is nothing but when you are drawing a ball, the probability of getting 1, which is equal to 1 by 4. And the right hand side is P of V into P of G. So P of E is again 1 by 2 and P of G is 1 by 2, which is equal to 1 by 4. So it is again valid. So the third formula is also valid, right? So what can you say about this? E and G are independent. But then even though these three formulas are satisfied, you cannot directly declare that E, F and G are independent. You have to even verify this, right? So how can you verify this one? See this. So what about E intersection F intersection G? In intersection we have only one element, which is 1. Then what is the probability of getting a 1? It is 1 by 4. Therefore for left hand side we got 1 by 4, and for right hand side here it is 1 by 2 into 1 by 2 into 1 by 2, so which is going to be 1 by 8. Therefore this formula is not satisfied. So they are not independent events. So what can you say? They are pairwise independent, but when all the three are taken together, they are not independent. Therefore the answer should be they are not independent. Got it? So which means they are dependent events. Okay. So how can you understand it? Whenever we are talking about more than 2 events, it is not just sufficient that these 3 equations are satisfied. You have to satisfy all the remaining equations, right? So in case of 3 events, we have to check these 4 formulas. In case of more than 3, which means for 4 events, we have to check how many? 6 plus 4 plus 1, 11 formula, right? So likewise, as the number of events increase, the number of formulas you might have to verify are going to increase to test whether they are independent or not. For that reason, you will not see a lot of questions in GATE. about 4 or more events. At most you can see 3 events. That is why I am taking this example. Got it? And this example is very important because even though all the events are pairwise independent, but they are not independent taken all together. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.